Please feel free to subscribe to this sideshow and append any comments and questions, which I shall endeavour to deal with to the best of my theatrical propensities.
Right, I've got a couple of problems here which I'd posted on Facebook, and I've been asked to explain how these are done. So here goes. Right, the first question is 8 girls and 4 boys stand in a row, like that, to be photographed, but the boys must be isolated from each other. Okay? And what is the probability of that? Well, let's see. Let's see, we've got 8 girls. 1, 2, 3, 4, 5, 6, 7, 8. Now remember, these are all distinct individuals, so the number of arrangements of these 8 girls is 8 factorial, which means 8 times 7 times 6 times 5 all the way down to 1. Now there are 4 boys, 4 boys, and the first one can be put in 1, 2, 3, 4, 5, 6, 7, 8, 9 places. Then there are 8 places available, so the next one can go in 8, and the next one can go in 7, the next one can go in 6. So that's the total possible number of arrangements. Now there are 12 people altogether, so the total number of arrangements, mixing them all up, would be 12 factorial. And that is essentially it. You can simplify that a little bit. There's 8 factorial. This would be 9. If you added on more there, that should get down to 1. You could write that as 9 factorial, but you multiplied this by 5 factorial, so you must do the same down here. And this would be 12 factorial, 5 factorial. And that's easily worked out on a whiz box. Now we go to the next, draw our little ring. And again, you've got 8 girls. So let's put them in. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Right. And you've got 4 boys who must be inserted in the gaps. Right, there are 1, 2, 3, 4, 5, 6, 7, 8 gaps. So the first boy can be put in 8 different places. The second boy in 7, the third boy in 6, and the last boy in 5. For the girls, there's 8 girls there, and the number of arrangements for the girls will not be 8 factorial, but 7 factorial. Now this is a big bone of contention with some people, and I'm going to explain that properly in another video when I'm in a good mood. But for now, I'm just asking you to swallow that one, okay? And the total number of people here is 12, but they're arranged in a ring. So again, I'm going to ask you to swallow this, that the number of arrangements there will be 11 factorial. And so that can be simplified slightly. We've got our 7 factorial here. You can write this one is 8 factorial, but that is a result of multiplying by 4 factorial there, so we've got to divide by 4 factorial here. So that would be 11 factorial, 4 factorial, and that completes it.
Please feel free to subscribe to this sideshow and append any comments and questions, which I shall endeavour to deal with to the best of my theatrical propensities.